Hello everyone, it's Benny, and welcome back to 2D RPG development. So, as always, there's a quick recap. So far, we've built a game engine, we've set up a player, we've set up items, and our player has an inventory now. So, all in all, we've done a pretty fair bit of work. But of course, it's not finished, so I think the next place we should go is we should start working on combat. Because we've got all the basics set up, now we need our player to be able to fight something. We need enemies, we need weapons, we need, just a basic combat system. And since combat is such a huge part of RPGs, I think this section is probably going to take up a couple of videos, so just be prepared. But I think we're just going to start with adding enemies and adding basic enemies can hurt the player, and we'll see where we can go from there. So, with that all out of the way, let's just go ahead and dive right into it. So, first things first, we need an enemy class. So I'm just going to right click on my game object package, create a new class, and I'm going to call it enemy, the enemy class. So, like everything in our game, it's going to extend game object, and there. So now all we need to do is and Control-Shift-I to import the game object class. So now, all we need to do is we need to set up everything that our enemy class is going to have, and this will just be the basis of every enemy we create. So what is every enemy going to have? First off, like the player, our enemy is going to have some statistics. So I'm just going to create private stats called stats, and the neat thing about this is, since we're using the same stats class for player as our enemy, all of the enemies will have, of the same level, will have the exact same combat benefits as a player. So it will be very, very well balanced in the end. So, now we have stats, what else does our enemy need? Well, our enemy is going to be attacking our player at some point. Or, possibly it could be attacking something else. So, I'm just going to create a private game object called target. Target. And this will be just whatever our enemy's pursuing, whatever it's trying to kill, it'll be its target. And if it's equal to null, then the enemy will just do some patrolling. So, that'll just be for basic AI. And other than that, that's really all the data I can think of the enemy needing, for at least the time being. We're probably going to go back and add more, but for the bare basics, that's all I can think of right now. So, we'll just go with that, and we'll add on to it later. So, of course we need a constructor, so I'll just create a public enemy. And in here we'll initialize stats, so stats equals new stats. And by default I'm going to pass in 0 experience, and we'll just see where we go from there. So, no experience, and now we need a game object, so, or we'll need to initialize target. I'll just set target equal to null. Even though it should be null by default, I'm just going to explicitly set it to null, just to make it clear that that should be a valid thing for our target to be set to. It doesn't have to be set to something, because of course the null target will mean the enemy is just patrolling. So, I think that's all our constructor needs for the time being. And now we need to get into methods. What is our enemy going to need to do? First off, obviously, it's going to need to attack. So, I'm just going to set this to public for now, and we can change it to private later. Yeah, I'll do it like that. So, public void attack. And this is where our enemy will attack whatever its target is. We'll also have public void, I'll just call it idle. This is where it will do whatever its idle function is, whether it's just standing still, it's looking for its enemy, idle function. We'll have a def function, so this is what in the enemy dies. So public void, I'll just call it die. And Actually, I'm going to have a separate idle function. I'm going to call it look. Actually, I'm just going to do all in the idle function. What I was thinking of doing is having an idle function that the enemy starts in, and that's where, if the enemy doesn't have a target, it will be looking for a target. But I actually like that idea, so I'm going to do it here. So it'd also have a look function. And this is where it will look for target. So look. And really, I think this is all we're going to need for basic AI. But of course, now we need to actually call it. So I'm going to override the update method. So public void update. And this is where we're going to sort of call all these methods we've created based on the information we have. So, first off, if we don't have any target, then we're going to call the look function. Because after all, that's the whole reason we just created that. So, if target is null, then we're going to look. Okay, that's simple enough. So, if our target is not null, then what we're going to want to do is we're going to want to chase the target. And, really I should have a separate chase function too, so I'm going to go ahead and add that. And again, if this proves to be too much, we can always just easily go back in and change this. So public void chase. If we have a target, then we're going to chase that target. And so that's the basic pursuit code at the very least. Now, attacking, I'm going to skip for a moment because we're going to need something else. So I'm just going to put in here attack call. And then now I'm going to try calling the def function. So that's actually easy enough as well. So if stats dot get current health, if that is less than or equal to 0, then that must mean that logically we've died. So if stats are less than or equal to 0, then we die. Simple enough. And, really, once I have the chase function, I really don't need the idle function, so I'm just going to delete that. But, these methods are really sort of... I kind of want to say they're a little bit artistic. You can really play around with it depending on how you want your AI to work, but really I think these 4 functions right here, they're good enough for basic AI, so this is what I'm going to do. So anyways, now we need to call the attack function. So attacking can be a little bit strange, because first off, we could, theoretically, be attacking from a long range. That's reasonable enough. Enemy has some ranged weapon. They shoot fireballs, they shoot arrows, maybe it has a machine gun. I don't know. They have some sort of ranged weapon that they can shoot the enemy with. Or, I shouldn't really say that since we're talking about the enemy class. They can shoot their target with. So, that's one consideration. But we could also have some enemy that has some melee weapon. So it uses claws, it uses fists, it has a sword. I don't know. It uses some close range attack. So attacking is going to be a little bit tricky. So, I thought I was going to call this all in the attack method. I'm still debating on if I'm going to or not. And in fact, I think I am. So, what I'm going to do is I'm going to have some method that checks if the target is in line of sight. And if it is in line of sight, then it's going to call the attack function. And then from the attack function, if the target is not within melee range, it's going to use some ranged attack. And if it is in melee range, then it's going to use some melee attack. So, simple enough. But now we just need to have some way of checking if the target is in line of sight. And first off, I think that's something that could be reasonably done in several different classes. So I'm actually going to create a new package for this. Actually, I'm not going to create a new package. I'm just going to create a new class. New package would be a little bit extreme. So I'm just going to right-click on my game. I'm going to create a new class. I'm going to call it util. So I'm just going to hit enter. And this will just be all my utility functions. So, first off, I'm just going to create a public static void, since we want to call this method without having to instantiate the utility class. And this is just going to check if something's in line of sight. So I'm just going to call line of sight. It's going to take in 2 game objects, game object 1 and game object 2. And for now, I'm just going to actually it's going to be Boolean. What am I doing? And for now, I'm just going to return true. I'm just going to Control-Shift-I. I'm just going to assume that the target is in line of sight, because really right now, we don't have any obstacles. Our world is empty. So this function can come later, because it sounds big, it sounds complicated, it sounds scary, and we don't need to worry about it. So I'm just going to leave it blank. So, there. That solves that problem. So, now we can implement this method. So if line of sight And actually, I need to put all of this in parentheses. So, because we really don't want the player, or not the player, we really don't want the enemy to be trying to attack a player if it can't see it, or if it doesn't have a target, so, yeah. I'm just going to put all this in the else statement just to prevent that from happening. So anyways, back to the if statement. So if util dot line of sight between this and the target, so if there's a line of sight, then we're going to attack. And I'm debating on whether we need a system for having it in the enemy class, or whether we should just implement this based on... Yeah, I think we'll just implement the whether it's melee or whether it's a ranged attack in the actual children of the enemy class. So, for now, I think this is good enough. I'm going to leave it like this. Although, there's a couple of things here that I see that I really don't like. First off, I want all these functions to be protected, because it could really screw up the system if we start calling the look function from outside the class, outside of this system. So, I'm just going to set them all to protected, so that way nothing outside the class can reasonably affect it. So, we have them all set to protected, and now we should really start setting up a constructor, because our constructor really isn't finished. So, first off, like all game objects, I'm going to take in an X position and a Y position, and I'm also going to take in a level, whatever level we want the enemy to be. So, as always, I'm just going to call the init function. I'm just going to call it just.init because I still don't remember it. So I'm going to pass in x, y. For red, I'm going to pass in 1. For green, 0, and blue, 0. It's just completely red. Size x will be size. Size y will be size. And type, we can just be 0. We don't need to distinguish enemies, at least for the time being. So size, we need a constant. So I'm going to... Actually, no, I'm going to leave this to the children. So we're just going to take in a level in our constructor. So, now the only issue we have left is we need to find some way of getting level turned into experience, because we're taking in the level we want the enemy to be, but our stats takes in experience. So how are we going to do this? Well, first off, we're going to need the function we created in the stats class, so we're going to need this done in the stats class, one way or another. And also, that makes it easy if for some reason we need to get level into experience at some other time, we can do that here. So, in the stats class, I'm just going to create a static method that will convert experience to level. And, okay, so I'm just going to go ahead and go right down here and just create public static void level to XP, takes in an int level, and actually it should return an int. Yeah, it returns an int for experience. So, now all we need to do is figure out why we're getting an error. Why are we getting an error? Missing O. I'm just going to return 0, so that goes away. And now we need to figure out how to actually do it. Because one option would be just to rearrange this monstrosity of a function, but I really don't think any of us are really feeling up to that. So I'm just going to create a really simple function for it. And this is not the best way to do it by any means, but, you know, it works. So, what I'm going to do is, I know that experience, right here, alright everyone, I'm sorry, I'm back, but I just realized there was a much easier way of doing what I was trying to do. So I'm just going to scrap this entire system we were doing to converting level to experience, because it's just stupidly complicated, and we don't need it for what we're going to do. So here's what I'm going to do instead. I'm going to create a second parameter in the constructor of statistics. And this will be a boolean. It's going to be boolean, I'm going to call it level or XP. And, actually I'm going to call it levelable. And what this will determine is it will determine whether or not these statistics can be leveled up. And that might not seem particularly useful, but believe it or not, this one variable right here is going to make a world of difference. So, I'm going to keep track of it up here. It's going to be, again, private boolean. It's going to be called levelable. And in the constructor, the very first thing I'm going to do, this dot levelable is equal to levelable, whatever they pass in. And again, I know this seems a little bit weird, but trust me, this is going to make a lot of sense. So, here's the logic here. If it's levelable, then we have to pass in some experience, because of course they need to be able to gain experience and then level up. But if they aren't levelable, okay, you with me on this? If this statistic system cannot level up, then logically we won't need experience in the first place, because the level will always remain the same, and our enemies are not going to level up. So, what this means is, if I'm not levelable, I can completely ignore this whole getting level based on experience system, and I can just return some level they pass in. So, that's exactly what I'm going to do here. I'm going to say, if levelable, so if we are being able to level up, then we're going to assign this dot experience equal to experience. Else, we're going to say this dot xp is equal to -1, just to signify that it's not levelable. And we're also going to need to keep track of levels. So I'm going to create a private int called level. And in here, I'm going to set this dot level equal to 1, just because, you know, it can possibly speed things up. So, and I also need some parentheses now. So otherwise, if we're not levelable, we're going to set that to the -1, and this dot level equal to whatever they pass in as experience. Of course, casted to an integer. And there. So, what all of this lets us do is, now that we're keeping track of level, if and only if we're not levelable, in our level function, we can say, if not levelable, then we're just going to return level. And that solves this entire issue right here. Very simple, much easier than what I was trying to do. I like this system, so there. And now that we have the system in place, there's a couple of things I could do to optimize this get level function, but I'm not going to worry about it. All we need to worry about now, though, is that our player and our enemy need an extra parameter. So first off, our player is levelable, so I'm just going to pass in true. Simple enough. So, our player is levelable, but our enemy is not levelable. And we're just going to pass in level and false. So there we go. I like this system a lot better than what we were doing. I think it makes our lives a lot easier. So now we've pretty much completed the enemy class, at least for the time being. The only thing we need to do is we need to go above the update method and add @override, or else NetBeans will hate us forever, even though it adds absolutely nothing to the functionality. But NetBeans insists. So, now that we have all that, I can right-click on my GameObject package and just create a new Java class. And we can create our first enemy. So what do we want our first enemy to be? Me personally, I want our first enemy to be the Cookie Monster, just because the Cookie Monster is amazing. So our first enemy is going to be the Cookie Monster. It's going to extend enemy, and it needs... Oh, we didn't add a constructor. But I can probably just solve this with Alt-Enter. Can I solve this with Alt-Enter? Will you let me? No, you will not, NetBeans. Okay. But in any case, we need a constructor, so I'm going to create public the Cookie Monster. Actually, just going to rename this to Cookie Monster, because that seems... just the Cookie Monster seems like too much text. So I'm going to call it just Cookie Monster. And I'll rename the file to Cookie Monster, so Java's happy. Refactor. There we go. Okay. So, now we're going to create the Cookie Monster. What does the Cookie Monster need? First off, it needs an X position, and it needs a Y position, and also needs a level. And that's all the information I want to set up the Cookie Monster. So, we're of course going to set this.x, well, excuse me, we're not going to do that, I forgot we have their amazing init method. So I'm just going to do this.init since I don't remember the parameters still. This.init, okay, takes in x, y, red, Cookie Monster's really bit blue, isn't it? So I'm going to put just a tiny bit of red, tiny bit of green, and a tiny bit of blue. Or excuse me, a lot of blue, because Cookie Monster's pretty blue. And there. And now we need size, so we'll just have a size for the Cookie Monster. And a type, it'll just be default. And now I can get rid of that, and I can create the size constant. So I'm just going to create private. It's going to be private static int size equals 32, because that's the size we've been using for everything so far. And now all we have left to do is we need to call the superclass constructor and just pass in level. And that will set the Cookie Monster theoretically to whatever level we pass in. But it's giving us an error. Can't be required given types. Oh, level needs to be an integer. There we go. So now we have a Cookie Monster all set up, but it doesn't really do anything. Although, even though I'm still just going to place it in the game, just so that we can have it there. So right here, I'm just going to object.add a new Cookie Monster. It'll be at position... I want it to be at position 300, 500. I'm pretty sure that's the position I'm looking for. And I believe we need to... It's not accepting it. Alt-enter. Add import. You know what? I don't care that NetBeans hates me for it. I'm doing that. Because it just makes so much... Why is this... Okay, fine. I will import everything individually because... I don't know, it hates me. And can't be applied to given types. Oh, I need to pass in the level. I'm just going to make a level 1 Cookie Monster. So, now if I run this, we should have a level 1 Cookie Monster somewhere on the top of the screen. So if I hit run, come on, we have a level 1 Cookie Monster, which is just this blue dot. Cool. Doesn't do anything yet, but we have a Cookie Monster. That alone makes our game amazing. So, now that we get rid of that, now we can actually set up the Cookie Monster and give him some AI and make him do some stuff. So, first up on the list is the look function, making him find some enemy, or some target. So, here's how I'm going to do that. I'm going to create, of course, the look function, so it's going to be private void look, and it should override the look function. Do I need to explicitly make it protected? Okay, it does need to be protected. I thought I could assign to private, but apparently not. So, look function. Here's how I want it to work. I want it to be so that, at least for the time being, if the player gets within a certain range of the Cookie Monster, then the Cookie Monster will find the player. Simple enough. But how on earth do we do this? Well, we'll actually need some more functionality in our physics class. So I'm going to go to my physics class, and first off I'm going to go ahead and fix the check collisions method, because this is really not good enough for what we want. So, here's what I'm going to make it return. Instead of returning a boolean, I'm going to make it return a game object. And instead of returning if it intersects, I'm going to test if it intersects. Then I'm going to return actually, I'm going to have just boolean res equals that, so we don't have to calculate it twice. So if we are indeed colliding, then I'm going to return the game object we collided with. So in theory, the way I want this to work is I want them to pass in themselves first. Well, actually, the question is, do you want it to be in the order of they pass in themselves first and then the object they're testing? Or the object they're testing? I kind of think it makes sense that they pass in themselves second. So that just makes sense to me. So I'm just going to return game object 1. So we're testing if GameObject1 is colliding with ourselves, which would be GameObject2. And if you don't like that way, you can do it with GameObject2, and you'll just need to pass in the physics parameters in reverse. I'm still not sure if I'm happy with that, but oh well. But anyways, if we aren't colliding, we're going to return null. And since we haven't done any physics calculations thus far, this won't have any changes. Need a semicolon. So this will just be a slightly better system, because this way we know what we're colliding with and not just that we're colliding with it. So, with that done, what we can do is, you know what, I'm going to change it to GameObject2, because I'm happier that way. So if we're colliding, we're going to return GameObject2, and yeah. So anyways, now that that's all cleaned up, we can actually implement this circle thing. And what this method's going to do is going to be very simple. It's going to be, of course, public static. It's going to return a GameObject array. It's going to be, I'm going to call it sphere collide. Even though it's technically not a sphere, this works for spheres, so yeah. And what this is going to do is going to check, it's going to return all game objects within a certain range. So what I'm going to do is, actually, I may need to move this out of the physics class because the physics class doesn't know about all the game objects. So I'm actually going to move this to the game class. And it'll just be a static method. So public static return void, not return, good lord. Public static game object array. Oh, come on. I'm pulling it together here. And it's going to take in, first off, a radius, so float radius. And actually that should be everything it needs to take in. It'll just need to take in a radius, and it'll return every game object within that radius. Oh, I also need some game object for reference. So I'm just going to take in float x, float y, and a radius. So here is how I'm going to do this. First off, since getting distance between two things, and that's what we're going to need to do, since getting distance is going to need to be a common operation, and we'll need to do it, I'm going to move it to the utility function. And I'm just going to create a utility method called public static. It's going to return a float. It's going to be called distance. And this will just be simply the distance function we learned in mathematics. And of course we'll need to take in two positions. So float x1, float x2, float y1, float x1, float y2. And it needs to be x2. I don't know why I put x1 again. And there. So now we need to set up the distance function. So the distance formula is simple enough. First off, I'm just going to create a float called x. That'll be x2 minus x1. And then float called y, which is going to be y2 minus y1. And now I just need to return a result. So I'm going to return, I'm just going to make this be a double. And the reason for that is I just want the extra precision in calculation. So first off, I'm going to cast whatever I return to a float. Then I'll do math.square root. And what do I need to take the square root of? Simple enough. It's x squared minus y squared, because these are already the x2 minus x1 stuffs. So x times x minus y times y. Actually, I think it's plus. I'm getting my distance formula confused. I'm pretty sure it's plus, though. Yeah, it's definitely plus. I don't know. I'm tired, I guess. I'm sorry. But anyways, now we have the distance formula set up, we can now perform this simple calculation, which, believe it or not, actually is really simple. So what we're going to do is we're going to create a game object array called result. Actually, I'm going to create a array list of game objects called result because it's going to be easier. So, and of course I'm going to initialize it. So res equals new array list of game objects. And what I'm going to do is I'm going to go through every single object in our objects list. So for I is 0, I is less than object dot length dot size, I guess, and then I plus plus. Or actually, we could just do a for each loop like before. That's probably better. So I'm going to do that. For each game object, go in object, we're going to do something. So all we're going to do is we're going to test distance. So if distance, or excuse me, util.distance, and we want it between go.getx and go.getY, and then we're going to test it with the two x and y values we have. So if that distance is less than the radius, which means it's within this imaginary sphere we're creating, then we're going to add that to the list. So res.add gameObject. And what this function is going to do, if non-static variables cannot be referenced from a static context. Oh well, I'll figure that out in a moment. What this is going to do is simply going to create a list of every game object that's within this sphere. And I'm just going to return this res.toArray. And there, that will simply cast it to a game object array. Just for make it much more specific. So there, that will just create a list of every single object that is within the radius that we decide. So now we have the issue of we're trying to create this as a static method, but Java doesn't really like this. So let's see what hints they have. Convert to for iterator? Yeah, no, I'm okay. So how are we going to get around this? And while this isn't the cleanest way to do it by any means, it's what we have to do. So what I'm going to do is I'm going to take off the static, because we clearly cannot do that. And what I'm going to do is I'm going to go to the main class. Now, since our game is kept track of here, and this class is pretty much static, we can create static methods in here that we can call from all of our from our children classes. Again, not the cleanest way to do it by any means, but it works. So I'm just going to create a public static void called sphere collide. And what this is going to do, public static void game object array called sphere collide, and it's going to take in an x, a y, and a radius. And really, we can actually just move this entire method over here. I'm pretty sure. Actually, no, we can't because that's private in the game object. What we can just do is we can just create a wrapper for it, so if this method, and just return game.sphereCollide using the same parameters we pass in. And now we have a pretty nice and simple way of doing it. And again, definitely not the best or the cleanest way of doing it, but for our intents and purposes, it works. So, now that we've done all of that, in our look method, we can just do, first off, we can create a game object array, which is going to equal main.sphereCollide. It takes in x and y and a radius, so I'm just going to take in our x and y, and for radius, for now I'm just going to pass in 128, and we can change it later if we want to. And this is giving me an error, semicolon expected. Not a state. Oh, I forgot to name it. So I'm just going to call it object. It can be called anything you want. Cannot find symbol, Control-Shift-I. Okay. Hopefully now we can do that. Now my next problem is I need a way of identifying the player. So what I'm going to do is I'm just going to give the player a type. I'm going to give it type 2 since item has type 1. And this way we just have a simple way of finding, if I can find my class again. Where's the Cookie Monster? There's the Cookie Monster. Okay. This is just going to give us a nice simple way of finding out what's a player and what's not. So I'm just going to go to for each object, go in object, or game object go, in objects, if go dot get type is equal to 2, meaning it's the player, then what I'm going to do is I'm just going to print out something for now. I'm going to print out the Cookie Monster sees you. I don't know, just something. So I'm going to go ahead and run, and we'll see what happens. One or more projects were compiled with errors. What is our error? Item class. Physics.check collision between this and player. Ah, so we did use it. If is not equal to null. That's what I'm going to do. If it's not equal to null, then we're going to pick up. So we have a crash. First off, cannot be cast to GameEngine.GameObject. Why on earth not? Okay. Well, too bad then. We'll just not have to cast it. Why didn't we compile with errors? Okay then, okay, then I can just return an array list of game objects instead, and just return res. And I can just go to main and instead change it to that. It's not what I would have preferred, since I don't want them to be able to, like, dynamically add to it, but, you know, if it's what we have to do, it's what we have to do. So there. Now it should run. Compiled with errors. We still have an error, okay. Why? I also need to change this to an array list now. And now that everything's changed to an array list, I can hit run. Now if we get too close to the Cookie Monster, it says the Cookie Monster sees me. And if I'm too far away, it doesn't see me. So okay, we now have a way of detecting if the player is within range. Yeah. Okay, so now, well, first off, I want a cleaner way of doing this, because really, I could theoretically change the player ID at some point, and I don't want them to have to memorize the number and whatever, so I'm going to go to my GameObject class. I'm just going to create a constant for it. It'll be just a public static final int called player ID, and a public static final int called item ID. And for now, I'm going to set item ID to 1 and player ID to 2. And the good thing about this is we can change this later. So now we just need to quickly go back for our code. So if our type is equal to player ID, since we should inherit the constant, so that should fix that. And that's the only time we use it. So other time is, actually in the player class, we want to initialize it to player ID. In the item class, we want to initialize it to, in the cube class, we want to initialize it to item ID. So, okay, I guess we do it in the item class. Where is, this .type is equal to item ID. Okay, there we go. And I believe that's the only places I used it. I don't know, we'll have to find out. Save, yes. Okay. So, actually we can delete this line of code, because we don't need it. And now I can go back to working on what I was doing. That was just a quick thing. So, with that done, now we can actually implement the seeing. So, now if it's a player, then we're just going to set target equals player. Actually, this target equals GO, excuse me. And do we not inherit this? Okay, I'm just going to create a method called setTarget. Just because we need a wrapper method for it. Or, not a wrapper method. A setter for it. Okay, so now I need the enemy class. And I'm going to create just public void setTarget. I'm going to pass in some game object, GO. And here we're just going to set target equals whatever they pass in. Simple enough. And there, that should solve it. And now that should mean that if I create the chase method and do at override in both of these because NetBeans insists for some reason. So now if I set up the chase method, I should be just able to print out the Cookie Monster is chasing you. The Cookie Monster is chasing you. And we'll see what happens. So now if I hit run, nothing happens. If I get too close to the Cookie Monster, then the Cookie Monster starts chasing me. Okay, excellent. So that code is working. Now we can actually make it so the Cookie Monster actually does chase the player. And it's actually a little bit simpler than it looks. So, for chasing, all I'm going to do is I'm going to have actually this should be public constant, public static final int. Not sure why it was just private, but oh well. I'm just going to create a constant for speed. Actually, we have stats, so I'm just going to use stats.getSpeed, so never mind about that. So, for chasing, what I'm going to do is, first off, I need the distance. So, actually, let me think about this for a second. Okay, yeah. We're going to use distance, but just not the one in our utility method, because we don't just need to know the distance, we need sort of some more information. So what I'm just going to do is I'm just going to create a float called nextx, which is going to be equal to target.getX minus rx. So what this value will literally be is it will be the distance between. Okay, you know what? Okay, I'll just sort that out in a second. Okay, but this variable will just literally hold the distance in the x-axis between us and our target. Easy enough. So now I just need to solve this error. And I'm really tempted to set this to I'll just create a getter for it. Get target.getX. Little weird, but whatever. It works. Just create public void get target, and it's going to just return target. And that way we have that extra level of security in case we ever want to change the way targeting works. So, unnecessary return string. Oh, no, it's going to be a public game object for get target. Okay. Simple enough. Is it still giving me an error? No. Okay, good. Now, next thing is we need a float for next y. So, same thing. So, our target dot y. So, get y minus ry. And now, that's all simple enough. So, but as you can see, I'm assigning the distance to our nextx value. So what this is literally doing as it stands is I'm going to eventually just assign x equals nextx and y equals nexty. Not sure why I tried it as a method, but I don't know. I think I'm getting a little bit tired from doing this for 40-some minutes straight now. But anyways, so yeah, what we're eventually going to do is this, and I'm just going to leave it like this because we are indeed eventually going to do it. But what this is literally going to do right now is just place the Cookie Monster right on top of the player, and he is not going to leave. So it's going to be like the Cookie Monster is literally just jumping onto the back of our player, not letting go. That's not exactly what I want. I want to chase the player. So first off, I'm just going to create a damping constant. So public static final int or yeah. I'm debating now. Okay. Here's what I'm gonna do. I'm just gonna create a damping constant called damping. I'll just make it int. I should probably make it a float, so I'm gonna make it a float. And I'll just set it to 0 for now. We can adjust damping as we go along. And all that variable is going to do is it's going to decrease our speed by a certain amount. So, yeah. So, here's how I'm going to do this. It's simply enough going to be if nextx is greater than our stats.getSpeed. We actually didn't set a way of doing this, so I'm just going to create a getStats method. under our enemy class, so public stats, get stats. It'll just return our stats. That should make this work. No? Okay, good. So if however far we're attempting to move is faster than how fast we're allowed to move, or excuse me, I should say that. If how far we're attempting to move is further than we're allowed to move, then we're just going to set next x equal to our getStats dot getSpeed. I'm actually going to multiply this by damping, which actually means I should probably set this to 1 so that we're not multiplying by 0. And yeah, and that will just make our speed take effect on the x-axis. And now we just need to do the same thing on the y-axis. So, same thing for y. And now, this should make the Cookie Monster chase us. Even though he's... Okay, no it doesn't. Interestingly enough, okay. Did I perhaps do it backwards? Is it supposed to be the distance between our x and our target's x? That's possible. So x minus our target's x. Okay. No. I'm gonna go with no. Okay. Okay, so I apparently screwed up somewhere. One moment, I'm just gonna look for my error so you don't have to watch me debug. And I actually did that pretty significantly wrong, so I'm just going to redo it from next x and next y. First off, next x and next y are not actually a position. They're the speed. They're how fast I should be moving in x. So I should call this speed x and speed y. And now the real next x and next y will actually... I don't even need that. I just need to set x equals x plus speed x, and y equals y plus speed and y. Now, all we have to do here is we have to test if speed in x is greater than stats get stats dot get speed times damping. Then we're just going to set speed x equal to whatever this number happens to be. Actually, so I'm going to use that number a lot. I'm just going to call that float max speed. I'm going to set it equal to that. That way I just don't have to retype that every time, because I'm going to need to do this in a couple of calculations. And all this is going to do is just going to make sure our speed never exceeds our max speed. And theoretically, we could also go negative in x, so I'm also going to check for negative. If speed x is less than max speed, so then we're just going to set speed x equal to negative max speed. Excuse me, less than negative max speed. There. And we're just going to have to do the exact same check for y. So, except this time it's just going to be speed y. And that should work. So if I hit run now, go near the Cookie Monster, you notice he's chasing me. And he is staying on top of me, because he's pretty fast. So I'm just going to set damping to 0.5f. That should make him move at half the speed. So now, as you can see, he's chasing the player. And just to make things more interesting, he's only moving in cardinal directions, because of the way the calculation works. But I kind of like that appeal, so I'm going to keep it. And yeah, so now we have the Cookie Monster chasing the player, if and only if he sees him. If I run and he doesn't see me, he never chases me, but as soon as he sees me, oh, he's after me. So there, he's now chasing the player properly, and everything's good. So great, we've implemented the look function, and we've implemented the chase function. And I think I'm going to actually end it here, because after this we're going to start getting into combat and combat calculations, and that's pretty much going to be a world of its own, so I'm sorry I'm going to have to end it here, but I hope you enjoyed, I hope you learned, and